Welcome to today's Explainer. I am absolutely pumped to get into this one. We're diving straight into the bleeding edge of autonomous agents and cross-network interoperability. We're looking at the Hermes ecosystem today, which is this incredibly fascinating intersection of self-improving AI, framework-agnostic agent communication, and trustless cross-chain asset transfers. Seriously, if you want to understand the architectural foundation of the upcoming agentic web, you are in the exact right place. So let's just jump right in.
Okay, here's our roadmap for today. 1. The self-improving Hermes agent. 2. The agent-to-agent protocol. 3. Comparing Hermes to its alternatives. 4. Cross-chain communication and ODAP. And finally, number 5, high-value developer use cases.
Section 1. The self-improving Hermes agent, autonomy at the micro level.
To start off, we have to understand that Hermes isn't just another basic prompt wrapper. It's a persistent, self-evolving system. Think about a closed learning loop. Say Hermes is tackling a complex task, maybe firing off 5 different tool calls to gather data. It doesn't just spit out an answer and immediately forget about it. Instead, it actually reflects on what it just did, distills that successful workflow into a reusable skill, and updates its persistent memory. So the next time you ask it to do something even remotely similar, it pulls directly from that newly created procedural memory. It's literally teaching itself. And it's got some serious technical advantages under the hood. For instance, it can use up to 8 parallel workers. That means it's executing multiple tool calls at the exact same time, which just massively speeds up those complex pipelines. Plus, it can write and run Python scripts locally over a direct RPC connection, saving you a ton of compute time. Oh, and you can deploy it on serverless architectures like Daytona or Modal. This is huge because the environment essentially hibernates when it's idle, making it super cost-effective, all while its autonomous curator quietly manages and organizes those learned skills in the background. You can even interact with it using voice mode via the CLI or Discord.
Section 2. The agent-to-agent protocol, collaboration at the meso level.
So now that we know how a single agent works, what happens when it needs a hand? That's where the agent-to-agent, or A2A protocol comes in. It answers a fundamental question. Who can help me? Imagine you have your Hermes agent, but it really needs to collaborate with an agent built entirely differently, maybe in LangChain. A2A enables these opaque black box agents to interact in a many-to-many setup without any prior hard-coded configuration. It uses standard HTTP to negotiate capabilities and actually delegates tasks using natural language. It's this brilliant interoperability layer that makes a real swarm of diverse agents a reality.
The way they actually find each other is through agent cards. Think of these like a digital business card for AI. They sit at a standard URL endpoint and lay out everything you need to know: the agent's decentralized identifier, its operational constraints, its trust score from peer agents, and its capabilities. And the coolest part? These capabilities use vector embeddings. That means the AI understands the actual concept, not just a keyword. So if an agent in Europe is offering a deluxe room, it can instantly match with an American agent asking for a premium room. The translation layer just intuitively handles that conceptual mapping.
Section 3. Comparing Hermes to alternatives, finding the right fit.
Let's ground this by comparing Hermes to what's already out there, starting at the agent level. Hermes is basically an always-on background daemon. It lives on your server, working 24/7, and you can chat with it across over 14 different platforms like Telegram or Slack. It remembers things you told it months ago. Now contrast that with something like OpenClaw. OpenClaw is fantastic, but it's an on-demand coding assistant with really deep IDE-centric integration. It doesn't have that built-in learning loop. They just serve totally different purposes. We see a similar distinction at the protocol level when we compare A to the Model Context Protocol, or MCP. MCP is highly structured. It's meant for agent-to-tool interactions, meaning the agent has to know the exact schema of the deterministic function call. A, on the other hand, is all about agent-to-agent delegation. You don't micromanage the target agent, you just use natural language to say what the task is and let that specialized agent figure out the how. So they are actually perfectly complementary. You use MCP to hook an agent up to local tools, and you use A to hand off a massive task to an external agent.
Section 4. Cross-chain communication and ODAP, securing the macro level.
Okay, so we have agents talking to agents, but what happens when money gets involved? How on earth does an agent in the US securely pay an agent in the EU? You obviously can't just send a standard HTTP request for something like that. You need highly resilient middleware to make sure digital value isn't double spent or just lost in the void across different legal jurisdictions. This is where we bring in the Hermes IBC relayer architecture. Written entirely in Rust, this relayer uses something called ODAP, the Open Digital Asset Protocol, to act as a secure gateway. It bridges blockchains that are operating under completely distinct legal frameworks. So it's not just passively passing messages. It's providing the actual technical infrastructure needed for regulatory compliance, making absolutely sure that a transfer on the source ledger is legally and accurately reflected on the recipient ledger. To pull this off and guarantee those critical ACID properties, atomicity, consistency, isolation, and durability, Hermes uses ODIP2PC. Basically, it's a crash fault-tolerant distributed recovery protocol. It breaks down into a three-phase commit process. First, it pre-locks the assets, then the gateways validate everything, and finally, it either commits the transfer or triggers a complete rollback. So if a node crashes or the power goes out mid-transfer, state is synchronized between the gateways, and those digital assets are never, ever lost in transit. It's a brilliant failsafe.
Section 5. High-value developer use cases. Putting it all together.
So how do we actually use this to save time or, better yet, make money? Well, at the software level, developers can deploy Hermes as a 24/7 enterprise office spot, continuously generating reports on Slack or running automated competitor monitoring for e-commerce. If you're in DevOps, it can monitor your logs, trigger auto-remediation scripts using its code execution capabilities, and ping your team on Telegram. But the real macro financial unlock is with those ODAP gateways. You can facilitate the transfer of cross-jurisdiction promissory notes. Imagine a supplier issuing a digital e-note on an EU blockchain, and an autonomous agent seamlessly transfers that liquidity to a US blockchain to finance a transatlantic shipment. The operational applications are just staggering.
We're going from a single agent writing Python in its own little sandbox to swarms of AIs negotiating in natural language, all the way up to cross-chain gateways transferring real-world assets across international borders. The pieces are all connecting right in front of us. Hermes is so much more than a coding tool. It's laying down the foundational infrastructure for a fully autonomous digital economy. The tech to replace traditional software pipelines is already here. So the real question is, when these machines are fully capable of negotiating, collaborating, and transacting entirely without us, are we actually ready for the agentic web? Thanks so much for joining me on this explainer, and I will catch you in the next one.